Okay, we are about 2 minutes in. I think we should get started. Hello, everyone. It's a pleasure for me to welcome you to this webinar. My name is Christian Frech. I am Associate Director of Scientific Operations here in Boston, and I'm also the Product Development Manager for RHEO, which I will present to you today. Together with me here today is Nathan Johnson from H3 Bioscience. So H3 was our first RHEO customer back in the days, like even before we started calling it RHEO. So hello, Nathan.
Hello, this is Nathan.
Before we start, just to let you know, feel free to drop us questions in the chat, and we are happy to answer them at the end of this presentation. We try to answer as many questions as we can, and we'll use the time we have available for that. And with that, let's move on. So before I jump into RHEO, let me quickly introduce 7 Bridges for those who are not yet that familiar with our company. So we are around for about 10 years, and we have grown into the industry-leading bioinformatics ecosystem, consisting of our award-winning bioinformatics platform. We have grown a team of over 50 bioinformaticians and bioinformatics engineers that provide expert professional services to our clients for helping with pipeline development and also designing analysis solutions. And we also provide access to some of the largest federated genomic data sets available in the industry, such as TCGA, Target, CBTech, and many others. So what does this 7 Bridges ecosystem allow you to do? Well, I would say it starts with the aforementioned easy access to public and proprietary data sets that you then can analyze on our platform, either using off-the-shelf cloud-optimized tools and workflows, or you use your own proprietary pipelines that you can bring to the platform. Then, of course, our platform allows you to fully leverage the computational power of the cloud for high-volume processing. And we believe that with these 3 capabilities combined, what we can do is we can significantly shorten your iterative data analysis cycles for the discovery of new drug targets and biomarkers. And this, in turn, of course, saving you both time and money. And what I should also mention here is that you get all of this in a fully reproducible, a secure, and compliant environment, which is very important for many of our clients. So at the heart of our ecosystem are 2 core technologies, Docker and the common workflow language. Together, these 2 technologies really allow us to describe your analysis pipelines in a completely environment agnostic and portable way. And so it becomes very easy for you to bring already existing pipelines to the 7 Bridges platform. But of course, as mentioned, you can also use our visual workflow editor. And you have a picture of this here, the Rubix Composer, to create new workflows in CWL and run them on the platform in a completely reproducible manner. So after this introduction now, this brings us to today's webinar topic, which is 7 Bridges RHEO. And, maybe let's get the most frequently asked question answered right away. What does RHEO stand for, right? So RHEO is actually not an acronym, but it's Greek, meaning flow or current. And it's the new brand name for our automation tools and services. And the goal of automation, when you think about it, is really to orchestrate the execution of your CWL workflows on the platform, and also to integrate them with your specific infrastructure. And this, in turn, significantly reduces the manual work that your users need to perform to run an analysis, and really reduce these manual steps to an absolute minimum. So you can think of this as a layer around, your CWL workflows, an additional layer that tries to streamline the entire analysis. So how does this work? Well, and from a technical point of view, RHEO really is what it does. It allows you to write custom Python scripts that have access to our 7 Bridges API and directly run those scripts on the platform. So it's a very simple yet powerful concept. And when we do this, we have the clear distinction here between the automation developers, who are those people who write automation scripts, and they express the flow of an automation in these simple Python scripts, which then get deployed on the 7 Bridges platform. And then the automation end user, as those who are either using the new RHEO visual interface, and we'll show this to you in a second, or the already existing the command line interface to run those automations with the push of a button. So they want to be the ones who run analysis over and over again without a lot of manual setup work and little room for error. So these are the components that the 7 Bridges RHEO product portfolio consists of. So we have on the left-hand side here, we have the automation development kit, which is a pair of Python libraries that we offer to speed up automation development. I'll show examples for this in a second. We have the command line interface, which is part of the 7 Bridges command line interface as a new subcommand. You will also see this later. To manage, start, and monitor automations from a terminal. And we have, on the right-hand side here, we have the application programming interface. So all automation services we offer are fully accessible also via the API. But for the probably more interesting thing for today also is the new visual interface, where we then, once deployed, we allow users to run an automation and manage the automation runs directly on the platform in their web browser. So for you as an interested user, when should you consider using RHEO? So there's a couple use cases we have in mind, and let me quickly go through these. So if your users run a limited set of analysis types over and over again on the platform, I think you're a prime candidate for using RHEO, and you will certainly benefit from this. So it makes your analysis solution very easily findable and executable at the central place on the platform, and I'll show this later in this meeting. And if you also think about how you can speed up your analysis setup and leave little room for human error, I think RHEO is also something you should look at. If you already use the 7 Bridges platform and you found yourself thinking about automating some of the following steps on the platform, so including, for example, creating new projects, importing files from connected cloud buckets, annotating file metadata, finding or copying the right CWL apps and reference files for your analysis, the process of setting up consecutive tasks and run them in the right order. Sometimes you might even have to tweak the instance types so that you are safe on compute costs depending on file sizes. Retrying transiently failed tasks, as rare as they are. So if they happen, they can be a bit annoying. So you might have to benefit from automating this as well. And also exporting the final results back to your connected cloud bucket, right? So if you already think about how can I automate this and streamline my analysis to make this easier for the platform users, then I think RHEO is really something you should look at. And of course, we also have clients who basically are saying we want to completely automate an analysis from A to Z, which starts from a sequencer streaming the data into the cloud, run an analysis on the 7 Bridges environment, and then get back the results maybe on their bucket. So even also that is, of course, a use case that we want to address. So just give you a quick impression of what RHEO, how it looks like. So this is how end users typically would interact with RHEO. Here is an example from the terminal, the CLI, and the way you can start an automation. There's a new subcommand, and then you give it the automation name, and you provide inputs in JSON format. So this is one way to do it for more experienced users, I would say. And now with the visual interface, a few screenshots here, you have a very easy way directly on the platform to provide the necessary inputs for an automation. Select maybe a file directly from a volume, from a cloud bucket, and then hit the run button, and then this goes into into execution. The GUI also gives you access to a run history, and then, as indicated here, deposits then the results on your bucket, so you have these data where you need it. For the developer who is writing automations, this looks a bit different. So here the process is typically starts with installing our automation development kit using a pip install command and pull these libraries from our internal PyP servers. Then they write this automation Python scripts locally in an IDE of their choice, PyCharm, Visual Code, whatever. And only when you find these automations to be working, you then start building a code package using a command that the ADK provides. It's called RHEO build. This is essentially a zip file, and I'll show this later. That gets pushed to the platform with a 7 Bridges CLI command. And then once it's on the platform, then as I already mentioned, the end users can use the CLI or the visual interface to run these automations. So when we talk about automations, there are three important concepts that we want to distinguish. We have, on the one hand side, left-hand side here, we have the automation top-level entity, which can consist of more than one code package, in which you can think of a code package as multiple versions of the same automation. And then each code package can be associated with more than one automation run, which are the executions of this code package. And I should also mention that automation entities have their own memberships and permissions. So for each automation, we can define who's going to see an automation on the platform. And they consist as top-level entities on the platform. They are not part of projects. They are their own independent entity. Inside the code package, we basically have our Python scripts with some associated config files that contain settings in JSON or YAML format, as indicated here. And there is a set of 3 files that are required for us to recognize this as a valid code package, where there's a requirements.txt file. There is an entry point file so that our execution service know where to start with the execution of this Python script. And there's also a schema file that's generated directly from code that formally describes all the inputs and outputs of this automation, so that the visual interface knows how to render a UI for these code packages. So the RHEO, I mentioned the RHEO Automation Development Kit. So what is the ADK, right? So the ADK consists of 2 Python libraries that we offer. One is called RHEO, the other one is called Hephaestus. RHEO is a general purpose Python library to turn a series of automation steps into a dependency graph for parallel execution. And this is completely agnostic to the execution backend, and you will see examples for this later. And then on top of this, we have Hephaestus, which is, you can think of as 7 Bridges binding for RHEO, where we offer a library of steps that perform frequent operations against the 7 Bridges platform, like copying files, running tasks. And then you can think of this as a wrapper around the 7 Bridges Python API. And these 2 together then basically constitute the ADK, and that's the libraries that you need to use to write an automation and if you want to put it on the platform. I should also mention that these libraries are not open source yet. So in order to install them, you have to be an authorized automation user on the platform, and you need your token to pip install them. And there's also additional documentation for this libraries that's part of this libraries when you install them. So that's also not publicly available. So I mentioned parallel execution. I want to briefly explain this concept here because I think it's a really neat feature of the ADK. So when you think about a typical automation script, it's not so much different from a workflow in the sense that it contains a series of execution steps with defined dependencies between them, right? So here on the left-hand side is a schematic example of what you would typically write in an automation script, where you iterate over a set of samples. You want to run 2 workflows for each sample. You run a first workflow A, whose output then should become the input of another workflow B. And then you can see how this establishes a dependency between those 2. And when you think about this kind of Python code here, this can be expressed as a graph, right? So, and where you say, we have now 3 samples. For each samples, we run 2 workflows in order, but then these 3, each sample can be processed in parallel, right? So this is then what the ADK does for you. It takes this Python, turns it into a dynamic execution graph, and then sends the execution graph for execution to the 7Bridges platform. So this makes writing automation scripts much less painful than using our regular API, because it takes care of all these dependencies. And of course, there's other benefits you get with the automation, with the ADK. I'll come back to this in a second. But first, here's a more like a real world example of what I've just talked about. So this is a somatic variant calling with a built-in conditional automation script. It's only a part of the script, but it shows you the important concepts. So how would you define so this is actual ADK code that you see here. So first notice how we define a step in this example, right? It's simply a Python class derived from the step base class. And in this example, we show only the main step of this automation, but there can, of course, be many more steps. Next, you see how we can define inputs and outputs of a step up here. Inputs and outputs both have a defined type, like string. Here, this is, say this is a volume folder, or this is an enum, which translates to a dropdown, which is an optional input. And so this is defined, and you can have a name and a description and a default value, which is not shown in this example. And here you have a defined output of this automation, which is a list of files, the VCF files that then contain our somatic variant calls. And the other outputs, which are for brevity, I'm not showing in this example. So each step then overloads an execute function and of its base class, and that takes the step inputs and typically runs other steps with them. So here you see we first iterate over a set of samples to run a BAM prep, which essentially aligns the reads and gives us some QC metrics. And then there's another loop down here where we, for each pair of BAM files for a case, tumor normal BAM, we run the somatic variant calling. And you can see now from the way this is structured that the inputs of this second somatic variant calling workflow are the output of the BAM prep step, right? So this is just regular Python. I'm referring to an output that I'm getting up here as an input down here. And this then establishes the dependency that I previously talked about. So this all happens then automatically. So you can also see then in the second loop that there's this if statement, which basically then makes sure that only for those cases where that pass QC, we actually run the second part of this workflow. And if you're familiar with CWL, this is sometimes a point of complexity where you have conditional execution. So this is one way to do it now with the ADK. So as I mentioned, during development, you typically run those Python scripts locally on your computer, which doesn't mean that the workflows run locally. They still run on the platform, but the Python script is executed on your local computer, which makes it much faster during development and testing. And only if you find the script to be working, then you will deploy it on the platform for your final tests and the production use. If you want to really see all the details for this example, there's a GitHub link here, and that's already public. And you can study like how this complete example looks like. And we also have a developer tutorial online that is a step-by-step instruction guide where you can learn how to write ADK scripts for the 7Bridges platform. So I mentioned other benefits of the ADK. So why is the ADK good for me and compared to writing plain API scripts? There's a couple of reasons. Besides the dependency management that you get for free, there are much fewer lines of code through the use of all the predefined steps that we offer. So for typical automations, you find yourself writing much less code to achieve the same. We have a built-in memorization, which is particularly nice. So when you run an automation script multiple times, it will be able to pick up the results from tasks that previously ran instead of running them again. So this makes, of course, the reruns much cheaper and faster. And only when inputs change, we re-execute a task. We have automatic retries built into our steps, which makes them much more resilient for failures that will occur once in a while. Could be just due to connectivity issues that you're having. And you get very comprehensive execution logs completely for free without littering your code with tons of logging statements. So this is also the indicators this under the hood. For each step that you run, it has this very verbose information of what's going on. That helps a lot during debugging and troubleshooting. So with that, I want to quickly jump into a live demo just to show you the most essential parts that I've just talked about. Let me switch over to, let me share my screen now and see if that works. So if everything works, you should see my console now. So what I will do now is I will show you how I basically take the example that you've just seen, this somatic variant calling code, create a code package from my local code, put it on a platform and run it on the platform using the visual interface. And then you see how this looks like. So let me first change into the right directory here. So this is essentially my complete code for this automation. You see how this is structured. There is a package called app, but this can be different. This is just one example. There's a main Python class, and I have a couple additional Python scripts. But this is up to you how you want to structure this Python code. The ADK doesn't impose anything here. This is a required structure here. There's a configs directory which contains automation settings in YAML or JSON format. So if you don't want to hard code things in your code, then you put it here. And this all settings defined here can be overridden at runtime, which is particularly nice. So you can parameterize the automation without changing the code or redeploying a code package. So now let me take this code and turn it into a code package using the RHEO build command that I've just mentioned. So, oh, sorry, I have to activate my environment. So let's try this again. Yeah, so this created now the zip file I talked about. We can look what's inside the zip file. This is really just a regular zip file. You see what files it put in there. There's now a file that wasn't there before. It's the schema file. This is basically the file that directly from the code, introspected on the Python code. It saw which input and output the main step defined. And it put a formal definition of those into schema file. And this is then the information the visual interface will need to render a UI for your automation, and we'll see this in a second. So now we turn to our 7 Bridges CLI for deploying this code package. So when you have installed the automation of the 7 Bridges CLI, you will find that there is a subcommand automations. So that's the one that we're using. And when we look, and then here are the list of subcommands that we have available. The one that we are looking at is the one for creating a code package. So let's try this command. Sorry, for creating the automation. We first create the automation by giving it a name. Webinar. So this worked, and you can see this. What I get back also is an ID of the just created automation entity. I'll copy this into my clipboard because I will need it later. And with this created automation, what I would typically do next is invite other members through this automation. So everyone who should be able to see and run it, I can now add them as member, or I can even add whole teams, very similar to projects. I will skip this step for the sake of time and directly start creating a code package. So now the next command is H3 automations, packages, create. And now let's just see the synopsis of this command. You can see that it wants an automation ID, a version, and the file, the code package file. So let's provide all this. So first we give it the automation ID. So next we give it a version identifier that needs to be unique. So if I have multiple code packages under a parent automation, each has to have a unique version identifier. So I start with 001. And then I provide the file, the code package that I've just created, the zip file. And with that, it will push this file to the platform and create the code package. And that's it. So now I have the code package on the platform, and I should be able to execute that. So I could also run this now from the CLI using the H3 automations start command. So that would allow me, as I've indicated in the slide before, to run this automation from the command line, but I now will directly switch over to the visual interface and show you how it looks there. I think that's probably more interesting for most folks in here. So let's go back to our browser. Basically, I'm now on the 7 Bridges platform. And this is an interface you will be familiar with. This is how it looks like after logging in. What you haven't seen yet probably is that there's a new menu at the top, it's called automations. So you will only see this new menu item if you are an authorized user for automations. And we can talk later about how you can get access to automations. But essentially, we will have to flag you or to unlock automations for you. And after that, you will see this menu item. So let's quickly click on that. So what you see here now is a list of all the automation entities that have been deployed on the platform and that are accessible to you. So where you have the permissions to see them. You can see there's a couple of automations that were already available. And there's also the new one that I just created, which is this webinar one, right? So let's just click on that one real quick. And, it brings up now this UI for the Python code that I've basically just shown you. It turned all the inputs defined inside Python, inside the main step, into visual controls. So here I can now enter a project name. That's the one required input here. Let's call this webinar. And in addition, this particular automation asks me for, as an input, as a folder that's directly located on one of my volumes. So you notice that now you can actually pick inputs directly from your connected cloud storage, which is quite nice. So you don't have to, import anything first to a project. We can directly refer to inputs that are still on your own bucket. And there's already a default value that's configured, but that, of course, is also up for the developer to put a default there. In this case, I have a default that already points to a folder which contains the FASTQ files for this particular analysis. Now I also have here an input that controls where the outputs of this automation should go. And again, I'm basically pointing to a folder on one of my buckets. And there are some optional inputs and settings in addition that I don't have to, but I can provide. So this is also defined by the automation. There's this optional coverage that defines a coverage cutoff. So that determines whether or not we want to proceed with variant calling for a pair of PAM files, depending on their median coverage, read coverage. These are additional settings I can give to the automation in JSON format. So everything I provide here overrides anything that's defined in the config files that I mentioned previously. And you can also supply additional settings. Secret settings are settings that you can put here, but they will never be shown again to anyone else. So if you have a password that this automation requires, that this is a safe way to provide this. We can also store secret settings, which I haven't shown, with the automation entity, and store it there. And so they are then at a safe place, and no other user will be able to access this information. There's a memory limit, which is by default is set to 500. And down here, we have an additional description, which I didn't provide for this automation, but I could have. And the outputs that this automation defines, including the VCF files that I mentioned previously. So now we can just go ahead and start this particular automation. Oh, sorry, I mentioned here is the place where you can select the code package of this automation you want to run. By default, you always run the latest code package, but you can refer to a previous version and then run this instead. So let's quickly execute that. And now this automation should start running. It's currently in created state. So it will, like, in a couple seconds, this will switch to execution. And while we are waiting, it's already running. But this automation runs a while, so that's why we now switch over to a previous result. So let's go back to the automations dashboard. Here is a webinar test entity I created yesterday, where I already ran this automation. You see this is the automation run list. It's a complete history of all previous executions. Each run has a name, who ran it, when was it run, which version was executed, how long did it run, what's the status. Here's a quick way to rerun an automation, preserving all the inputs with the same or different version, and you can then also, of course, change the inputs. So this is a very quick way to re-execute, also using the memorization features that I mentioned previously. So let's just look at the results quickly at one of those finished automation runs. It's exactly the same run, essentially, that we've just started, but in this case, it finished already. And you can see the outputs, right? So you define as a developer which outputs you want to put here. All these files point to files present in some of the projects that the automation created. Let me just show you quickly one of those outputs. This is a QC report. And when we look at this, this brings up basically a QC report. This is just multi-QC with various QC metrics across your entire cohort. So that's a very quick way to inspect, what's going on with my data. And so the automation defines what is exposed here to the user, right, without giving them access to all the other 100 files that they might not need to know about. The last thing I want to show is that this data gets directly deposited back to the bucket. So if I go to data volumes, this is my demo bucket that I'm using for this. If we scroll down here, this is the output folder that was configured when I was running this automation. You can see that after running this automation, like all these result files are already in my bucket, right? So there's no extra step for export necessary anymore. I think I'm at the end of this. Just see if the other run was started running. Yeah, so this is running now, but this will take a while until it's finished. So that's fine. I can also stop this now because I don't need to wait for it to finish running. And that will now go into an aborted state. And that's it. We can get to questions later, but at this point, I think I'll turn off my screen share. And I want to hand over to Nathan, and who talks about the H3 use case.
Thank you, Christian. So my name is Nathan Johnson, and I'm an investigator in bioinformatics and data science at H3 Biomedicine. As Christian mentioned, H3 has been a user of the automation framework for a couple of years now, which is why they asked us to be part of this webinar. So who is H3 Biomedicine? H3 is a US-based in Cambridge, Massachusetts, where we are focused on precision oncology research and development as a subsidiary of ASI for almost 10 years now. We are primarily a preclinical discovery company, but we do also have several ongoing clinical trials from some of our preclinical discovery from a couple of years ago. Data science and bioinformatics is at H3's core as an integration component to the clinical, biology, and chemistry aspects. This is emphasized at H3, where in every project meeting will include representatives for each of these typically separate fields in order to provide domain expertise, which is essential at each aspect of the preclinical discovery and clinical research. Furthermore, this is expanded by the fact that our president is actually a bioinformatician and data scientist, which is fairly unusual in the pharmaceutical space. Our process to preclinical drug discovery centers around different milestones represented as proof of concepts, or POCs. Each of these POCs milestones focus on the modulation, validation, developability, translation, and pharmacological and clinical aspects of these different compounds that are being developed. Each of these aspects utilize a wide variety of data types and data analysis criteria. As our focus is on the clinical relevance of drug development, our primary focus isn't on software engineering, but rather on how to integrate the biological relevance to the data analysis conclusions. Data analysis efforts utilizing bioinformatics in the modern computing environment primarily focuses on cloud-based computing. While there may not be a need for all companies to adopt this policy, it was essential at H3 given the large volumes and variety our data analysis required. While our focus is on data analysis, in order to achieve quality analysis at scale typically requires four main objectives that can be filled by a single individual or by multiple people, as each of these aspects can be quite complicated and integrated. These areas are the computing analysis infrastructure that maintains the parallelization, whether on a single computing resource or across multiple. The pipeline management workflow manager that details the data input, output definitions, the data processing logic, and the algorithm execution. And then deployment, which will require multiple users, consistent pipeline execution, and data syncing. Then the final output of all this information is input for data analysis, where it is important to understand the algorithms so that biological insight and results can be explained to a diverse audience. Tool development and deployment are not the same thing. When testing or developing a new algorithm, typically on a local computer or a single computing instance, the computing infrastructure is fairly straightforward, where the data input, output, resources, and computing environment can be easily defined. However, when you expand this development space to multiple users, it puts the additional requirement of consistency, version control from the data, input, output, both the results and the raw data, as well as the pipeline, all with a computing environment that scales. So at H3, several years ago, our original solution was take advantage of Luigi as a workflow management scheduler, which if you come from the high performance computing environment could be equated to Slurm. This solution allows you to manage our AWS EC2 instances, S3 data storage, and integrate our metadata across the cloud-based environment. But if you notice, there are different people tasked with managing different aspects, such as the environment or cluster manager. The solution worked for a period of years, but quickly became painful in terms of maintenance, as the code base for Luigi is not simply designed like other modern workflows, such as Common Workflow Language or our Nextflow. So H3 had to come to a decision point on what to do with this. So the big question for us is, what is the cost of internal maintenance for all this information? So how much time and resources do we spend, such as myself, maintaining a pipeline and not actually analyzing data, which is our goal? But also on top of that, what happens if a developer leaves a company? What happens when the code breaks? What happens when dependencies change? And what happens when the automation has limitations in terms of the resources that we use? All these aspects come at a cost in terms of hours and salaries from different people required to constantly maintain this. And since our focus is on the data analysis rather than software engineering or the environment, we decided to go with 7 Bridges. And so what we decided to do a couple of years ago is that we replaced our pipeline maintenance with 7 Bridges. So as you can see around the red box where we mentioned H3 pipelines, we replaced this with the 7 Bridges icon an environment where we can be able to define the pipeline code, the environment, as well as the computing resources, so we get a focus on data analysis rather than maintaining all that software infrastructure. And the nice thing about that input and output is now that it can be synced up to our S3 buckets, which then can be read in from our other platforms that are used for analysis. So at H3, this is our development concept at the moment, where we have weekly conversations with 7 Bridges to define what project specifications we want. 7 Bridges will develop this. We'll develop a scope as well as a time frame it would take, as well as the resources that may require to develop it. Then they'll give us it as a branch on GitHub as a testing where I or anybody else on the team is able to test it, as well as do some basic deployment testing on some of our data sets. And then if we are happy, push it to the main branch of the platform. And so this way, the rest of the team can have access to the latest and greatest in terms of the project. And so by having this back and forth, this conversation, we are now able to be freed up in terms of having to maintain all this pipeline, but we have the extra benefit of being able to keep updating our internal pipelines. So as part of, just to give an example of how we use this, similar to what Christian had shown, having an environment, common environment, specify the input and output and how we run the version control. You'll see at the very bottom the results of how it's talking to the 7 Bridges platform, where you have that hash ID. That'll give you a log file that you can identify it. Then if you go into the GUI on the platform interface, you can see that project being automatically built, where we also have internally all the members who are assigned automatically. And then you can see in real time the different aspects being executed. And then on the right-hand side is the GUI interface for all the different automations. So we internally have documentation so that you can run everything on the command line, but also there's ability to do this on the GUI in case a user prefers that option versus the command line. And so the nice thing about this is that you can have the flexibility of the cloud computing, but the flexibility also for myself in terms of being able to parameterize the different aspects that we're trying to run. And then that I'll turn over to Christian for questions.
Thanks a lot, Nathan. We are now ready to take questions. So please feel free to enter questions into the chat. And we have, I think, plenty of time to answer those questions. So while we're waiting for questions to come in, maybe we can also talk about like frequent questions that we heard in the past. So one question, of course, is always like, is RHEO available on all platforms? So what we currently do is we offer RHEO only on commercial platforms, both in the US and Europe. And it's not yet available on the academic platforms. And currently also don't have any plans to offer it there. So in case you want to get access to RHEO, I think the best way to do it is just to drop us a note on the website, and we will get then in touch with you. So as I mentioned, automations are and you need to be tagged as a user to be able to use it, both from the CLI and from the UI. So if you want to play around with it, just give us get in touch with us, and we'll find a way to give you access. So I don't see questions in the Slack. In the chat. So, another questions that we frequently see is, how does this ADK or automation scripts relate to CWL, right? And I pointed out similarities, right, where you see, there are, both automations and CWL basically string together a set of analysis steps, and then but I think there are some important distinctions. So we see automation really as a layer around CWL to make the execution of CWL like easier, right? It's basically the process of embedding a portable workflow into a specific execution environment to make it truly push button, right? And by definition, this last mile, like the last part of a solution, cannot be portable, right? Because it is specific to, let's say, your bucket, where you say, oh, my reference file are at this location, and I want to tell the system to take it from there automatically without the user making this decision. So if you code this logic into an automation, you lose. I mean, this is no longer portable, but it also cannot be portable, right? So this is where we say it makes sense to create CWL for everything that you want to be portable, right? But then you can use automation as something as the last ingredient to make things a push button for your end users. So that's really how we approach it. And also when so we got a question here on the chat now. How do you deal with debugging? That's a really good question. There's two sides to this. One is automation development, as I mentioned, happens typically on a local computer, right? So there it's not so much different from writing any other or developing any other Python script, right? You see all the exceptions on your computer, and that's just fine. So you resolve all the errors as they come up in your Python code. Once it's deployed on the platform, what I didn't show you, but what we have is we give access to the automation execution logs, right? I can probably quickly turn on my screen share just to show this aspect. So when I go to one of those automations that actually finished, so let's pull one of those up from yesterday's run, like here, for example. Here you can download the log file, right? And this log file is even available while the automation is still running. So there's a small delay of 2 or 3 minutes, but even for running automations, you can pull the log that's written to the console typically when you run locally, and then inspect this log. So this helps, of course, to troubleshoot errors that come up for platform executions. And as I mentioned, these logs are really comprehensive, very verbose. So you shouldn't have too much issues to figure out what's going on if in case you run into an execution error. I hope this answered this question. Yeah, I see that my screen wasn't shared, unfortunately. I still see the spinning wheel. I'm sorry for that. So another question. You mentioned that RHEO makes it easier to integrate with a private cloud compared to previous 7bridges offerings. As someone who hasn't used the 7bridges platform before, could you clarify what you mean? So private cloud, so what I've shown here was the bucket integration, right? So it's basically the situation where clients like H3, but also almost all other automation clients, maintain their own cloud bucket, and they prefer that all the input data stays there, and also all the output data should go there. So here, automation, what it can do for you really is to integrate these S3 buckets that you own with the 7bridges platform, right? And this becomes then for end users becomes one integrated solution. Another aspect to this is since this is basically regular Python code that we are running with automations, right? And you can use this Python code to reach out to external services, external APIs to achieve what you want, right? So that's doable. So as long as your infrastructure, let's say it's already cloud-based, you offer some API, then you can use automation code to integrate with that and run it on the platform. So that's another aspect where I would say it's useful for integration purposes. There's another question was here, is training offered for RHEO developers? Great question. Absolutely. So we I would even say we would strongly encourage for everyone interested in this to undergo training with 7Bridges. I would say we have really good documentation, and in fact, we do have internal developers, IDK developers, that completely self-onboarded, just let's say using the tutorial. So that's certainly possible. But I would definitely recommend to get a training from 7Bridges and then to facilitate and speed up the process of onboarding. And we are happy to do this with you. Another question that came in on the chat: how does RHEO compare to other automation solutions available? Another excellent question. Of course, there's a lot of things out there, and in many aspects, of course, we didn't reinvent. This is not a new innovation. Let's, for example, this concept of dynamic execution graphs, lazy evaluation. This is, if you ever worked with TensorFlow, for example, that's a similar concept there. A very popular automation solution framework, I think, is probably maybe Airflow, right? I think we even have clients who use Airflow for automation purposes and run everything on their own local infrastructure, which certainly works. I would say what distinguishes RHEO is that everything is still inside our secure and compliant environment, and you get a visual interface for free, right? So if you use something like Airflow or maybe even Nextflow or other workflow frameworks to achieve the same thing, you still struggle with how do you roll this out to a large user base, right? You might run it, you might have a script running, but how do you make this easily executable, and how do you make this completely reproducible to have and complete audit logs, right? How do you facilitate collaborative debugging, right? So that, when something breaks, that there's multiple people that could easily look into the problem and see what's going on, and maybe even fix it and rerun it without the users being even involved, right? So these are, of course, all benefits that you get with the platform. And I think by having automation scripts on the platform, you get access to all these value propositions that the platform has. So I think in my mind, this is the combination of a very nice, ADK that makes the development, simplifies the development considerably, and that other frameworks would do the same. But the combination of that with the platform, I think, is really nice, and that we see this in practice every day when we collaborate with our clients. So another question here came in. While not available on academic platforms, is there a particular use case in academia where RHEO could drive research initiative? Yeah, as you could say, automations would be useful for the academic platform as well, right? Because one of the stated goals here is really to simplify the process of running an analysis, right? If you ever worked with CGC, for example, it's great. It offers you tons of flexibility as a user, right? You can, you basically pick your own tools and workflows from our gallery. You string something together, you run it, you tie it into data sets that you query on the CGC. But also, sometimes because they're so flexible, there's a lot of steps usually you have to go through. So there you could say making this push button, right, has also value for the academic platforms. But as I said, currently we don't have plans to bring automation as a feature on academic platforms. So there's one other question here. Where do you select which machine you want to run your analysis on? Our specialized machine available, for example, FPGA, I could see only where you could set memory limits. Good question. So this decision about instances you run on is taken care of by the workflow that are orchestrated. So I mentioned automations is essentially a wrapper around our CWL workflows, and as part of these workflows, then oftentimes define what instances they need to execute. So that said, we already on the platform, we already have execution hints, right? So if you run a workflow, even though the workflow might predefine a certain instance that it uses, you have at runtime, you always have the possibility to override the setting. And nothing stops you from exposing this setting also at the automation level, right? So you could just say, oh, let's have another automation setting or another automation input that allows a user to configure what instances should be used. And then this is then used as an override when you actually start the workflow for execution. So that would work. That's one aspect when you want to manually control it. And I would say another nice thing about automation as a wrap around CWL is that now you can have smart decision points, right? Where you, instead of always running the workflow with the same instance type, if your goal is really, let's say, to optimize cost or runtime or both, then you can put some nice little logic inside the automation script and say, hey, let me look at the input for this workflow and let me see how big it is. Like, is it a small file? Is it a huge file? And depending on this information, you might decide to run the workflow with a different instance setting. So this also now becomes available by having this nice little wrapper around your workflows and have it all executing on the platform. So I don't see additional questions on the chat right now. We have 2 more minutes, so please, if you... here's a follow-up question from Louis. On my previous instance questions, can you set some runtime cost limits? Yes, so for steps that run tasks on the platform, the ADK has a runtime limit parameter. So this is nice. So you can now say when you kick off a task with the automation, you say, if this task runs longer than 25 hours, then kill it, right? And the automation will do this for you. So that's part of the one of the gimmicks that you get when you start using the ADK instead of just having to write this with your own API scripts. Cost limits we currently don't have in place, where you could say, if this compute costs more than X, then also abort it. That's something we currently don't offer as a feature. But that's an interesting use case. Okay, we are reaching the end of this webinar. I think right now it's at 12 o'clock. So let me probably finish by saying a big thank you for everyone attending here. If you have more questions that we didn't have time to answer in this session, feel free to reach out to us. It will find me, and then I'm happy to answer any additional questions. And I think with that, I will close this webinar. So thanks everyone again for attending, and I hope that we sparked your interest into looking more into RHEO. Thank you very much.